Hope you guys are able to see the screen.
Yes, sir.
So we are in the third cycle. We are completing the first part of the third cycle on how to do how to read from a sun path diagram and how to calculate on the azimuth and the altitude angle. In today's class, what you look into is the exercise on calculation of vertical and horizontal shadow angles. So this would be primarily useful for you in designing your shading devices. So shading device is normally what you call as a chaja, the projection above the windows. So how are we going to determine what is the length we have to use to protect our openings? So that is one part. And then we look into what are the various types of shading devices. Okay. So in this part, we learn how to calculate the angles first. So if you recall, there's something called on how to read the sun path. There are primarily two things what we take into consideration. One is the azimuth angle and the altitude angle. So you guys are able to see the screen? Guys?
Yes, sir.
Yeah. This is a website called Andrew Marsh. Can you guys please note it down? If possible, if you can open up another tab, you can open up the tab. The web page link is given. So Andrew Marsh is a very a dedicated website which can give you sun path in a 2D as well as a 3D. And there are various parameters and various types of charts in which you can look in from. So in this, first thing, we'll go on to the chart. What is a different type of chart? So normally, the sun path, we preferably take it from the stereographic sun path. So this is what gives you the sun path, the stereographic chart. Now we'll set up a latitude and longitude to understand what is the location. So for Chennai, my example I'm taking for Chennai, ours fall under the 13-degree north latitude. And the longitude for Chennai is, anyone can say? What is the longitude for Chennai? $80. And I keep the time zone as, we fall into the 5:30 plus 5:30. But there's no fraction on that, so it's okay. So this is a sun path, what we see for Chennai. And here we can process on which part of the year, what is the date, which date we need to find the sun path. You don't need to worry on the 2014, which has been marked here. That's not a problem. It's the same all throughout the various years. So this way you'll be able to figure out. So on an example, if I can say, in January, if you see the midpoint is what we locate as Chennai is. And the red line, what we see is the sun path for the day. So in this, we can see I've set an example of 25th January. And here I can start the timings. So there's some problem here. Just a minute. I think there's a problem with my mouse pad. So as of now, it's 20th. Okay, I'll go back. Okay. Just let's just reload the page. Why is okay? 10:30. So here we can see how the sun path starts off. So at 5:55, you can see at the extreme east is where the sun's starting. That is a sunrise from the horizon. And as we move further, what is the angle it's going to take? At 7:35, the position of the sun, you can see the azimuth angle, as I said, which is calculated from the north. So it marks on to a degree of 103.74. And the altitude angle is what we take from the extreme end. The center is 90. The concentric circles is what we determine as the altitude angle, the height at which the sun is. So this falls into this red dot falls into the lines, the two concentric circles between 20 and 30 degrees, which you can see here. So the time altitude angle is 22.91. So this is the primary readings with which we're going to follow how to design a shading device. So what is the first criteria we are going to take into designing a shading device would be what is the hottest part of the year. So for us, we look into May. So I'll take May 29th because I've already worked out on that. It's like, see, every year there is a hottest period, hottest day, and the hottest um, time in a day. It's not, it can be varying from 12 o'clock to 3 o'clock. So with the climate data, what we can take from the meteorological department, there's a climate data compilation for 10 years minimum. That's where we can take a reading from. Anything less than 10 years, we can't take a data which is applicable for only 1 year because we go through a constant climatic change. So we have to take a mean data of minimum of 10 years duration and come to a conclusion on which is the hottest period of the year. And in that, the subcategory is what is the hottest period in a day also. So, example, I put it for 29th May, which I assume to be the hottest day of the year. And the time in which we're going to take would be, I think, 12 o'clock. Okay. So now, if you see where the sun's path is, as I told you, the center is what Chennai is located. The sun is on top of us, which is on the northwest side of us at 12 o'clock. And we can see what is the azimuth angle, minus 31.45. Here they have taken a minus reading. Otherwise, if you want to have a positive reading, all you have to do is 360 minus 31.45 will give you the positive angle, which would be somewhere around 330, 329. And what is the altitude angle? Altitude angle is what is the height in which the sun is going to cast this shadow down, what is going to beam down. That is 79.83. So here, I want to show you a representation, how these formulas work. Just a minute. So I'm going to work on a paper. So I'll log in from another device. So that I can show you. Stop screen. Are you guys able to see the? You guys are able to see the paper now?
Yes, sir.
No?
Yes, sir.
Wait, I'll stop the video. Able to see it now?
Yes, sir. It's visible.
Yes. Okay. So for an example, I'll just do a circle to simulate the sun path as in the stereographic diagram. You guys are able to see? Okay. North, east, south, west. So as I said, the sun's position is somewhere here. The time for which we have taken. So the time and date for which we are going to take is 29th May 12:03 p.m. So the azimuth angle for this time, azimuth is what I say from the starting from north as a 0 and where we are going to be. So the position is here. So this position at that point of time is 325 degrees, 325.37 degrees. And the altitude angle for that time is 79.43 degrees. So altitude angle is nothing but, imagine we are standing here, a person standing, and what is the point from which the sun is casting his angle? So this is the altitude angle. So this is 79.43 degrees. Now, the first thing what you're going to do is we're going to calculate the angle of incidence. The angle of incidence is nothing but if there is a surface, drawing it in isometric, there is going to be a perpendicular face, as in there is going to be a perpendicular line from the wall. This is the wall which is facing the northern side. So this is the north wall. And this is the perpendicular line what you're going to draw. And now I take a imaginary position for the sun. So I do a perpendicular line of the sun to the ground. Perpendicular. And with determining the azimuth angle. So this is the angle in which the sun is showing, casting his rays at 12:03. And now, just a minute. Just a minute, guys. And now I'll take a angle which is going to be perpendicular, which is going to be casting from the sun, from the top. So I've got a triangle put up here. The line showing from the top where it's casting onto the wall, and one which is perpendicular to the ground, and I'm going to make a note. And this would be another reference point which I'll take from the sun to the perpendicular line. So there are going to be three angles here. This one is called the gamma, or Y. This one, this angle is called the delta. And this angle, as in from the angle from the sun to the perpendicular line, is called the beta. So these are the three angles what we got. In this, the azimuth angle, which is the delta, what we have is like we have to find out what is this angle. We know what is the angle of the sun. So the altitude angle is this. Gamma is nothing but the altitude angle. So we know one angle, which is the altitude angle. And now, as I said, this is the azimuth angle. We have to find what is the perpendicular line we're going to take. So, as I told you, the angle, this is the azimuth angle, what we have. So, to find delta, all you have to do is, what is this perpendicular line facing into? Which is the perpendicular line, what I'm saying is nothing but Chennai's location is here, the north is here. So, which means the perpendicular of this north wall is 360 degrees. You can take it into two conditions. Either we can call it 0 degree or we can call it 360 degrees. The reason why we call it 360 degrees is because we have come from the north and how it's going to face it. So what I take is, now to find delta, I'm going to do 360 degrees minus, what is the azimuth angle? 325.37 degrees, which is 34.63 degrees. So now we got two angles, which is the delta and we got the gamma. The gamma is nothing but this. So the important formula what you have to remember while taking this is, this follows the principles of trigonometry. This is not a very complex but simple one. You can easily able to understand it. Cos beta. Beta is, we have to find out cos beta. So cos beta is cos delta into cos gamma, which is cos 34.63 into cos 79.43. Use a scientific calculator and you'll be able to find the values, which is 0.822 into 0.183. So these are the values of cos 34.63 and cos 79.43. Now multiplying these both, we'll get the value of 0.14. So this is our cos beta. To find beta, what you do is, we take the cos to the other side. This is what we call as cos inverse. Cos minus 1.14. This again would be found in our scientific calculator and you'll end up in a value called 81.95. The angle of incidence. The angle of incidence is nothing but what is this angle of the sun with the perpendicular face of the wall, which is beta. See, there are two things what you have to understand. We are going to design shading devices. Primarily, there are two types of shading devices: horizontal and vertical. So hope you guys are aware of there is vertical shading device also available. Example, if there is an opening here, the one projecting on the top, these are the horizontal shading devices. These are the vertical shading devices. So what are the conditions in which we're going to use horizontal and vertical shading devices? When the sun, with respect to the sun path, when the sun is on the move and it's on the lower angle, which is primarily from the east onwards, we use the vertical shading devices. And the time when the sun reaches the altitude, which is the right above the top, then we use the, sorry, when the sun is from the east, when it's moving on to the side and it's on a lower altitude, we use a vertical shading devices. When the sun rising to the top on the higher altitudes, then we use the horizontal shading devices. Similarly, when it's going on the west, we tend to use a vertical shading devices. So here we're going to calculate two different things. We have to know about horizontal shadow angle and vertical shadow angle. When we speak about horizontal shadow angle, when we are going to try to find out what is a horizontal shadow angle, we will be primarily working with horizontal shadow angle is nothing but the sun is here, it's going to cast this shadow, and this angle to the perpendicular, this is the horizontal shadow angle, which is represented by delta. A vertical shadow angle is nothing but I'm hitting the shading device and I'm coming down here. I'm again doing a perpendicular. This angle, what we going to take, we call it the, you can call it beta also, or the shadow incident angle. This is the vertical shadow angle. Normally what we call is epicenter. Epicenter is sign represented by E. Okay. So these are the two shadow angles in which we work. When we are saying about horizontal shadow angle, which means we are working on the vertical shading device. It's right the opposite. When you're trying to find what is the horizontal shadow angle, then we are working on a vertical shading device. Similarly, when we are working on a vertical shadow angle, then we are going to work on a horizontal shading device. So I'm going to just give you a small idea about how we are going to find out this shadow angles. So I have a wooden post. And imagine I'm going to have a sun. If the sun is going to cast its rays, so what happens is the light comes from this side. Eventually, it is going to bring a shadow. This part is the where we can see a shadow distance. So now there are two criteria in which we're going to take the height of the object. Is my screen clear? Guys? Yes, can you please respond? You guys are able to hear?
Yes, sir.
Yes. Okay. So this is the height of the object. There's one criteria. Another one is,
So it has a problem focusing.
okay, because I'm holding it on the hand. Okay, I'll try to hold it steady. The length of the shadow. Okay, let's call this B. And let's call this A. A simple trigonometric formula to find out what is this angle in which the shadow is going to be cast. A trigonometric formula is tan theta is equals to height of the object divided by length of it. So in this, we'll be able to find out. So I've got an example here on to find what is this length of the shadow. The reason is normally this theta value is what we arrive from the angle of incidence. The theta value is nothing but the angle of incidence, for which we have a formula to find out how to get the angle of incidence. Now to find out what is the length of the shadow, what we do is example. I'll take the previous example only, which is the angle of incidence what you have found is 81.95. So tan 81.95 equals to what is the height of the object? I assume the height of the object to be the size of a window, which would be normally 4 feet. So I give 1.2 meters. And the angle, the length of the shadow, which I've not found out. So which we'll find out now. So what is the formula would be? Tan 81.95 is nothing but 7.07 equals to 1.2 by A. On the inverse, it is A into 1.2 by 7.07. So the value you will get for this is 0.16 or 16 centimeters. See, this is a very hypothetical value which I've taken. So what it says is the length of the shadow here is 16 centimeters. So in this case, when we are doing a shading device, when the angle of incidence is going to be 81.95, and this is what is going to bring my shadow angle, I can design a sunshade, which is the hypothetical value, with just 16 centimeters. Normally, but in default, all our places in our houses, we have a sunshade of 0.45, 1 feet 6 inches. But when we are very precise, we are sure about what is the climate data we got. And when we are going to design a shading device, we can find out the values easily. I know this is a bit of too much of calculation. Just guys. So yeah. So this is quite a bit of calculations involved in this, in designing a shading device. So what I suggest is I want you guys to relook into the video and try taking a value. You can use the Andrew Marsh website to get the data for one particular period. This could be any place, even your own local city or town. You can understand what is your discomfort climate time and take a data for that particular hour and find out the azimuth angle and the altitude angle and work out the same exercise which I worked out here, and you'll be able to end up designing your own shading device. And with that, I'll just want to add out what are the various types of shading devices which is available. So the different types of shading device available, what we use is a vertical shading device and a horizontal shading device. This is an example of our vertical shading device. This one at the top, the one at the top where when we call a vertical shading device, we tend to call it as fins, the vertical fins. So the fin at the top is a perpendicular to the wall, whereas these fins here are inclined to the wall. So how these delta values and how to find out, interpret all of these are given here. So these are the horizontal shading devices, which is like what we conventionally use in our homes. And the epicenter, the angle of incidence, what is required is given here. And this is called egg crate. Egg crate is because it is a combination of both the vertical and the horizontal shading devices. And here you can see an hexagonal shading device also. So there's multiple variations on that. So designing of the shading device, this is regarding. So what you can see here is the temperature data given at the top, and here is a time. So there are various versions of these charts available when we go on to find out climate data, which says at what are the various times and the heat is more, the temperature is more. One you can see at the center is what the maximum temperature is. So I'll just stop with this. We have another 3 minutes. So all of this is from the Koenigsberg book. Here is a formula on how to calculate all of these. You can refer to the book also. So guys, I know this is a bit too much. So what I want to do is, if you have questions right away, you can ask me now. Otherwise, if you want to go through this video, do an exercise, and then you have a question also, you can reach up to me. Any queries for the session now?
Sir, the angle of incidence part, can you just run through it once again, please?
Yes. Just okay. Okay, you're able to see the screen here. So this is from
Yes,
the book.
sir.
Yeah. The angle of incidence. See, there are two things we are going to have. One is the gamma. Gamma is nothing but your solar altitude angle. Altitude angle, what we get from the solar chart, that is what we get as gamma. So we know what our altitude angle is, which is the sun from the top, sun's angle from the top, which is coming down. Next is what we have is the azimuth angle. Azimuth angle is nothing but this angle, the line what you see here. This is the azimuth angle. This again, we know about it. But whenever we are going to do a shading device, we have to take the perpendicular direction. The perpendicular direction of from the wall, whichever side. It could be east, it could be west, or it could be south. So this, to find out this perpendicular angle, even though we are finding out for the azimuth angle at this period, so what we do is, whatever is the perpendicular, imagine if your wall is facing east, then your perpendicular angle is 90 to the azimuth. If your wall is facing south, your perpendicular angle to the south is 180. If your wall is facing the west, your perpendicular angle to the west is 270 degree. And the perpendicular angle to the north is 360 degrees. Okay. So this way, you will find out what is the perpendicular angle. How to find out is the azimuth angle, whatever could be. Imagine I'm taking at 4 o'clock in the evening, which is on the western side. The sun would be on the west because it's going to set. So what I'll do is, I'll find out it could be 260 degrees. So I'll take the perpendicular angle of the west, which is 270 minus 260 is what I'll end up